Okay, so this one, radical versus exponent form. So we already know that a 1/2 is the same as doing a what? Square root. And technically, this would be where your 1 goes, and this is where your 2 goes. So in math, we usually just write that, but it is really doing that. The square root is in math just like that. Okay? So then what is the square root of 16? 4. Okay, so how do I change this radical into an exponent? So the cubed root of 27 is the same as doing a 27 to the 1/3. And then if I could simplify that, what is the cubed root of 27? 3. Okay, this time I put the 5th root of, so then this would be the same as a 32 to the 1/5. Good. And you can actually do this. Can you think of something that goes something times something times something times something times something to get to 32? 2. Okay, so 8 to a 1/3 would become 8 to a 1/3, like that. Okay. Normally, you can see that I don't normally write my 1 on there. Okay, because anything to a 1 you don't need. Cubed root of 8 is 2. Okay, x to the, anybody want to take a guess at how that would go then? X to the 9/5. Did you say like this? Yeah. Okay, so x to the 9th has a 1/5, but then it would really become 9/5. Okay? Okay, so here, the radical, so I'm going to put the 16 in there. And how do you put a 3 somewhere and a 4 somewhere? 16 cubed with a 4th root. Okay. I don't know if you're ready for this. I can do this math without my calculator. Here's a question for you. What is the 4th root of 16? 2? 2 times 2 times 2 times 2, right? Then what is 2 cubed? 8. So that's the answer on that question. 16 to the 3/4 equals 8.
Will we have those on the test?
Yep. But we'll do a little bit more of them. Okay, and here's a check to see, did we do stuff right? 16 to a 3/4. There we go. It's 8. Okay, on this one, when I'm doing a square root, what's really in the front there? It is a 2, right? A square root is always doing a second root. So this would become x to a 7/2. Okay, and if you like to think about it like that, it's an x to the 7th getting a square root. Okay, so this one, where are you going to put the 5? Where are you going to put the 7? x5, and it's a 7th root. So whatever's on the bottom is the root that I'm taking. Okay, looking at this, would you notice that each one is a 4 on the bottom? So would this make sense? That I'm taking a 4th root? Do you see it? 4 on the bottom, 4 on the bottom. So that's a 4th root of and then I have an x cubed and a y1.
Break them off the 10 and you just do what we were doing before.
Sorry, say that again.
Like if they're not the same, then you make them.
Yeah, we would have to write them separated. Yeah. Okay, and then this one. So I would put a 9x4 in there. And you don't have to write the 2, but that's what's happened, right? A square root of 2. So what is the square root of 9? 3. And then x to a what? 2? Yep. Oh, we still have 2 more to go here. Okay, last couple. Square root of, so again, when you do a square root of something, you do a half. Okay, and I'm not gonna make you evaluate that one probably because the square root of 7, well, square root of 7 you can't really do anymore. But x to a, what would it land as a number on the x? 4. Okay, this one, what am I noticing? There's a 5 on the bottom and a 5 on the bottom, so I'm doing a 5th root of stuff. Okay, and then this last one is a cubic root. So 1/3. And then 27m9. Okay, so what's the math on the coefficient? So what is the cubic root of 27? 3. And what's the rules on the exponent? Multiply, so 9/3. Okay, this is it for today. I just want to explain the difference between these 2 questions. Okay, so here, the coefficient has to get applied there. So 16 would need that on it, and the base would need, exponent would need it on it. Oh, I got fuzzy, sorry. So the square root of 16, I'd have to change that to 4. Okay, what is different about this question? the 16 isn't involved in that exponent. That exponent is not applying. Okay, so do you see how the 16 is in a bracket? So the 1/2 applies to it. The 16 is not in the bracket. The 1/2 doesn't apply to it. Okay, so just be careful with sometimes with math, the bracket situation.